Here we're given an equation, a really long equation, where our biggest exponent is 3. We know it's an equation because there's an equal sign, and it already equals 0 for us. Whenever we're given a problem like this, we want the problem to equal 0 because that does make the problem a little bit easier for us. So anytime you get an equation and you know you're going to have to factor because you see a lot of terms here, make sure it equals 0, and if it doesn't, you can make it equal 0, and I'll have another video about that shortly. So what we have to do is we have to think about all the different types of factoring that we've discussed. The first one is finding the GCF. You have to look and see out of all your terms, is there a common number or variable that you can take a GCF out of? Well, as far as numbers go, I see 9 can go into all of these, but 9 cannot go in here, so that's not part of the GCF. I see that these 3 terms have x's, but because the last term does not have x, that is not part of the GCF. So it looks like we don't have a GCF here. There is no number other than 1 that can divide evenly into all 4 of these terms. Another type that we've discussed before is the box method. We typically have 3 terms that we're adding and subtracting together. Usually the biggest exponent is 2. And that's when we form a little box and we use the GCF to figure out what the 2 factors are. Well, because we have 4 terms here, that's not going to work so well. There's another type of factoring we've discussed that is factoring by grouping. Factoring by grouping, typically you start off with 4 terms. Sometimes you have an exponent that's bigger than 2. So for instance here we have an exponent of 3. And it looks like this is going to work. It looks like this shows all the different signs of a factoring by grouping problem. So what I'm going to do is I'm going to group the first 2 and the last 2 terms. Notice how I'm not using parentheses to group them. This is something that I've talked about in a few of my classes. If you use parentheses to group them, it causes a problem at this point right here. Because you can put the parenthesis here, but then it looks like you can distribute that negative, and really we can't. We're just combining these like terms. Also, if you put a parenthesis over here on the other side of that negative sign, it'll appear that when you put your parenthesis here that you're multiplying these two, and that's not the case. We're adding and subtracting all these terms. So that's why I like to keep an underline underneath. If you have different colors or highlighters, that would be a smart move to do that, or you can do different squiggly lines just to keep them separated. But in this case, since I have different colors, I'm going to use that. And the purpose is you take each group and you look at just this group, just these 2. What is the GCF of just these 2? Go ahead and write it down. Well, notice they don't have any number in common other than 1, so you could put a 1 down, but I don't typically do that. It's okay if you do, though. I do say that I have an x in common, so I know x is part of my GCF. And whenever we look at GCF, when we have exponents, we always look at the smallest exponent because that can divide evenly into both of these, and it's technically the greatest. So it looks like we're going to have an exponent of 2 because out of these 2, the exponent of 2 is the greatest. Now remember, this value must equal what we're going to put down here, so I have to put parentheses. And in order to get what is inside the parentheses, this is what we're doing. We're factoring out a GCF. We have to divide each term by the GCF because what we're doing is opposite of distributing. When we distribute, we multiply this term inside the parentheses. But when we take the term out, we're going to divide. So I'm going to divide each term by x squared. When I do that, that's going to get me x. I got x because when you divide, you subtract exponents. So you technically get x to the first power, or just x, plus 9. I got the 9 because here, x squared divided by x squared, the x squares cancel out and it just leaves a 9 left over. So the thing about this that I really like is when you have factoring by grouping, whatever is in here must be over here. It must be the same exact thing. So we're still going to have an x plus 9 on the inside. However, I have to figure out what I factored out of here. What is the GCF, or what is the number that I factored out of here in order to get an x plus 9? Well, I know if I divide both of the terms by 9, that gets me what's on the inside. Except notice if I were to go back and check my answer and distribute, 9 times x is not negative 9x, and 9 times 9 is not negative 81. So in order to change those signs, I should make this 9 a negative. Now let's kind of go back and check. Negative 9 times x is negative 9x. That looks good. Negative 9 times 9 is negative 81. Okay, that looks good as well. So at this point, let me go ahead and change the color here. This whole thing still equals 0, the whole thing. Now I need to continue the factoring by grouping. I need to continue it because if you'll notice, these two products share a common factor. Remember, a product is two things that you multiply together. So these two things that we're multiplying together is a product. These two things that we're multiplying together is a product. And each product shares a common factor. Remember, a factor is something we're multiplying by. So notice how we're multiplying both of these terms have an x plus 9 on the inside. So we're going to factor that out. We're going to factor that out just like we would factor out a regular GCF. They both share an x plus 9. But then after we take away the x plus 9, we got to look at what's left over. You'll notice we have an x squared and a negative 9 left over. So that's going to go inside my parentheses, x squared minus 9. The whole thing still equals 0. And at any point what you can do is you can go back and check. You can, on a separate sheet of paper, multiply these together by using the FOIL method or the box method. And you should end up with your original question. You should always end up with your original question because it should always be equal. When you factor, you're just looking for a different way of expressing the same value. So before you do anything else, you got to think to yourself, what else can you do? What else can I factor? So I'm looking at this right now, the x plus 9. There's no method that we've discussed. There's no GCF. You can't use the box method because there's only 2 terms, not 3. So this really cannot be factored anymore. Now there's one method of factoring that we can use here that I have not discussed yet in the video because I knew we were going to talk about it again, is the difference of squares. So that's the 4th method. So we have total GCF, factoring by grouping, box method, and difference of squares. So difference of squares pretty much means you have 2 numbers, you can take the square root of them, and you're subtracting them, so it's the difference of 2 squares. So essentially, this x plus 9 has to stay here because the value cannot change. But if you look here, this can break up into 2 separate parentheses. I only know that because I memorized the formula. The formula is for difference of squares. So if you're not sure how to do the next part, please look at the formula for difference of squares. It's just pure memorization. Because if you know difference of squares, you'll know that your end result, you're going to have a plus sign and a minus sign. The square root of x squared is x, so x goes first. The square root of 9 is 3, so 3 goes last. And that's it. We have these 3 terms. Now, typically when we're just factoring, at this point we're done. We're done with the whole thing. There's nothing else we can do. But because we have this equals 0 here, that kind of changes things. So only when you have equals 0, and it's only when you have equals 0, I really want to emphasize that. That's very, very important. I'm going to pick a different color here. You need to set each factor equal to 0. So x plus 9 equals 0. X plus 3 equals 0, and x minus 3 equals 0. This is called the zero product property. And then what you have to do is you have to solve each equation. So you have to get x by itself. Here you would subtract 9 on both sides. Here you would subtract 3 on both sides. And here you would add 3 on both sides. But your end result, you will get x equals negative 9 as your answer, x equals negative 3 as your answer, and x equals positive 3 as your answer. So all 3 of these are your final answer. So the big question that I think a lot of people are still wondering is, well, what does this mean? Why are these three things my final answer? Well, there's two reasons. One reason is you can take any one of these numbers. You can take -9, -3, or 3, any one, and plug it into your original. Just pick one, plug it in. When you plug it in, you will notice that you'll get 0 every time. That's how it should work. Another reason why is this is technically a function. If you take away the 0 right here, which I don't think I can at this time, but if you take away this 0 and say, let's say it equals y, and you go to graph it, like on a graphing calculator, this graph will go through the x-axis at all three of these places. So technically we're finding the zeros of a function, and that's something you typically learn in Algebra 2, but we will be learning it in Algebra 1 when we talk about parabolas. So we won't have anything this complicated, at least not yet. But this is our factoring by grouping. What we did was we factored out a GCF, and we also used difference of squares in this problem.